Welcome to today's episode of Robert's Creative Chronicles. Today we'll be using Newton-Raphson method to solve this equation. We'll be using Newton-Raphson method. It's a numerical analysis method. So we're going to use it to solve this equation. They say use Newton-Raphson method to seek for the values of x for which the following function equals 0, given that the initial approximation x naught is equals to 1, f of x is equals to 24x cubed minus 14x squared minus 11x plus 6. So, for Newton-Raphson method, we have that xn plus 1 is equals to xn minus f of xn over f prime xn. So, where n is equals to 0, 1, 2, to infinity. So, and our x naught starts from 1. That means our approximation, our iteration starts from 1. Let's express this in terms of xn. 24xn cubed minus 14xn squared minus 11x plus 6 at the xn. Then f prime xn, this is the derivative of this function. So we are going to find the derivative of this function. To be 3 times 24 is 72 xn squared minus 28 xn minus 11. Derivative of 6 is 0 since it's a constant. So we'll start our iteration now. So start from n is equals to 0. When n is equals to 0, we'll substitute n equals to 0 into the equation, the Newton-Raphson equation. So when n is equals to 0, n plus 1, that is 0 plus 1 is x1, is equals to x0 minus fx0 over f prime x0. You see? So our x0 or x0 is 1 from the equation minus this one is this equation, or in terms of 0, 24x0 cubed minus 14x0 squared minus 11x0 plus 6 divided by the derivative 72x0 squared minus 28x0 minus 11. So we substitute x0 or x0 into these equations to find our answer, our first iteration. This is our first iteration. So 1 minus 24, 1 cube plus 14, 1 square plus 11, 1 plus 6, because our x naught is 1 over 72, 1 cube, 1 square, sorry, minus 28, 1 minus 11 So we just put this in the calculator now. Twenty-four. No, times 1 is already 1. Minus 14. Minus 11. Plus 6. Equals to 5. Over 72. Minus 28. Minus 11. 33. And substitute this into the equation. Is 0.8484 or 8485 approximately. So 0.8485 approximately. So our first iteration gives us this. So let's move to the second iteration. The goal is to get, when we start getting the same values of x, maybe we get a value first and we get the same value the second time, then we terminate our iteration at that point. So our goal is to find a value that if we substitute it into this equation, the original equation, it will give you 0. That means that answer is the root of this equation. We want to find a value that satisfies this equation. So when our value repeats, when the answers of x is the same, repeats twice, at that point, any iteration gives us the same value. So at that point, we terminate our iteration, and that gives us our answer. So the second iteration, n is equals to 1. Second iteration. So if we substitute the value of x, sorry about that, we substitute the value of n1, n is equals to 1 into this equation, the Newton-Raphson equation, we will get x2 equals to x1 minus f x1 over f prime x1. This equation. Where is x1? x1 is 0.8485 minus 24 x1 cube minus 14 x1 square, just to get this equation, minus 11 x1 plus 6 all over x1 square minus 28 x1 minus 11. Then we substitute the value into it. 4 Yes, there's a mistake. Minus 11. So we'll put the value in the calculator. 4. This one gives us 1.2483 8485 minus 1.2483 over 17.0786 approximate 17.0786. So now let's put everything inside. This answer is 0.7754. So our second iteration gives us 0.7754 to 4 decimal places. And then it's got to 2 now. These are third iteration. So when we substitute this into the Newton-Raphson equation, this one, it will be n is equal to 2. So 2 plus 1 is 3. Then it will be 3 is equal to x2 minus x3 is equals to x2 minus fx2 over f prime x2. So our x2 is what? From here you know that our x2 is 0.7754. 0.7754 minus the function 24 x2 squared minus 14 x2 24 x2 cubed minus 14 x2 squared minus 11 x2 plus 6 over 72 x2 squared minus 28 x2 minus 11. For now, we'll substitute this x2 into the equation. 754 cube minus 14 0.7754 square is 11.754 plus 6 over 72 0.7754 square minus 28.7754 minus 11. This gives us this 0.2421 divided by 0.85 approximately. So the answer is 0.7525 approximate. So these are the answer for our third iteration. So let's move, since this one is not the same with the last iteration, we keep doing it until we find a value that repeats itself. So then n is equals to 3. These are fourth iteration. These are fourth iteration. So as usual, x4 is equals to x3 minus fx3 over f prime x3. We know our x3, 0.7525 minus 24 x3 cube minus 14 x3 squared minus 11 x3 plus 6 divided by 72 x3 squared minus 28 x3 minus 11. 0.7525 minus 24, 0.7525 cube minus 14 0.7525 squared minus 11, 0.7525 plus 6, 72, 0.7525 square to 0.7525 minus 11. Sorry. Divided by minus 28 8.7005. So this one, the answer is 0.7500 approximately. Now let's do our fifth iteration. divided by 72 x4 square minus 28 x4 minus 11. 24 0.7500 cube minus 14 0.7500 square minus 11 0.7500 plus 6 divided by 22 7500 square minus 28 0.7500 minus 11. The numerator is 0 of that one, 0.7500 minus 0, into 0.5. So this 0.7500, since 0 divided by 8.5 is automatically 0. So our x5 is this. So now you observe that x4 is 0.75. x5 also is 0.75. So x4 is equals to x5. That means we can stop our iteration here. That means the root is actually 0.7500. This is the answer. You can cross-check it by substituting this value into the equation. Check. To the original equation, this equation, this one. So let's substitute it, you see. You see, this one gives me 0 on the dot. There are some that can give us 0 point something. They are also correct. Or this one is even perfect. That means the perfect root. This is a perfect root of this equation. So hence, this is a root of this equation and it satisfies this equation. So you can conclude that the root of the equation is 0.7500. Correct. 4 decimal place. Thank you for watching. I hope you understood how to find the root of an equation using Newton-Raphson method. If you have any question, feel free to write it in the comment section below. Thanks.